Graph this polynomial and again try and find vertex, x and y intercepts, domain and range. Like before, I'm going to try and put this in standard form. So I'll move the 10 to the other side. Now, let me just show you the way the book does it. Maybe you guys will like it better. I always move the 10 to the other side, but the book doesn't do that. So what the book's going to do is just say, you know what? Let's work with these two terms here. 2 times x squared plus 6x, and I still have the plus 10 here. Okay, so that's fine. But I've got to complete the square inside this polynomial. So 2x squared plus 6x plus something plus 10. So what is it that I'm going to put inside here to complete the square? 9. Now if I put a 9 here, what's the net effect to the right-hand side? I've really added what? 18. So if I add 18 to keep things in balance, then I have to subtract 18. So they're going at it a little different way than I do. Whatever you like. I mean, they both get you to the same thing. 2 times 9. So by putting the 9 here, I'm adding 18. To keep things in balance on the right-hand side, I'll subtract 18. So this becomes y equals 2 times something squared. 10 minus 18 is negative 8. What do I square to get this? X plus 3. Cool. Alan, can you read me off the vertex of this one, please? Perfect. Negative 3, negative 8. So there's your vertex. Let's keep track of a little series of points here. X and Y. Negative 3, negative 8. That's our vertex. Can someone tell me what the let's see, the y-intercept would be? 10. 0, 10. So 0, 10 for the y-intercept. And as far as the x-intercepts are concerned, I think there's a couple possibilities, but I think I'd go back to the first equation and try and find the x-intercepts. So why is that? Well, let's take a look at 2x squared plus 12x plus 10 equals 0. Any help with that one? I'd factor out the 2 first and get 2x squared plus 6x plus 5. Do I need to break out the quadratic formula here? You could, but it's like squirrel hunting with a bazooka. All right. So let's try and do something a little bit easier. 2 times x plus 5 times x plus 1 equals 0. And you can read off the solutions for x, right? What are the solutions for x? Negative 5 and negative 1. So x equals negative 5 or x equals negative 1. The values that would make this 0. Now notice, 2 can't equal 0. So this constant out in front doesn't really matter as far as where you get a solution. So when y equals 0, x is negative 5 or negative 1. Let's see if I have enough room. I think I have enough room to graph this except for perhaps the y-intercept. So let's put that on our handout. So we had a vertex at negative 3 and negative 8. So that's down here, negative 3 and negative 8. And we had intercepts at negative 1 and negative 5. You're just not going to have enough room on this graph to graph the y-coordinate of the y-intercept. It's okay. I think we got some of the important parts here. So just play connect the dots. Do that in a nice smooth way. And So you get a very tall graph, very narrow graph because of the coefficient of a 2 there. It's not something that I've said a lot about, but this equation does have an axis of symmetry. And that is x equal -2. That's actually a way to double check your work, is that that line that goes through the vertex and divides your parabola should have points equally spaced on either side. So 1, 2 to the right, 1, 2 to the left, we find intercepts. If your points are not symmetric around that line, then there's a problem. Where do you see -3? Or I mean -2? I'm joking. I'm joking. That's a -3. I corrected it. Yeah, thanks. Okay. Does anyone else want to make me look foolish here? No? All right. Oh, once isn't enough. All right. Let's see here. Now, it's nice that you can put this into this standard form. Okay? But sometimes all we need is the coordinate. All we need to know is, all right, well, where's that vertex? And there's a formula shortcut for that. So let's take a look at problem number 28 here. Here's that formula. If you want to know what the vertex is of a parabola, it's enough just to find the x-coordinate this way. X equals -b over 2a. Wow, really? That's it? So let's check it out. This isn't... It died here. It's not responding. Okay, well, I guess I can't zoom in or out. And anyways, -b over 2a. Well, a is 5, b is 30, c is 4, but c doesn't even enter into this formula. Okay, doesn't matter. The x-coordinate of the vertex is going to be -30 divided by 2 times 5. What would that be? Good. So -30 over 10 is -3. Great. Now if I want to find the y-coordinate of the vertex, then I can simply plug in a -3 here. So f of -3 would be, let's see, 9 times 5 would be 45, minus 150 is minus 105, plus 4 is minus 101. So there you go. There's your vertex. I put in -3 into this function. I hope I did my arithmetic right. We'll find out. Well, there's 2 points for the vertex, right? There's the x and y coordinates. Now, really, if you were clever, you might realize something about what we just did. This gives you kind of a back door into putting things into standard form. So that back door would say, well, gee, if this is my vertex and my coefficient of x should be this, I should be able to get away with a graph of y equals 5 times something squared. Can you tell me what I'm going to put in here for the square part? A little bit more than 3. I need an x. X plus 3 squared minus 101. Do you have 139? Negative 41? God, am I way off. All right, let's take a look here. All right. 5x squared plus 30x plus 4. And let's do a table here. So I want to type in -3. Oh, negative 41. Dang. How did I be so off? Negative 45. Oh, you know what? I was thinking of putting in a 5 here when I was doing that. All right, so negative 41. Let's apply some Photoshop here. Excuse me a second. There. It's Photoshop. This is a sophisticated operation. All right. 41, negative 41. And, oh, I guess I need a little bit more here. So, negative 41. All right, so this and this should be equivalent. So it's kind of a backdoor into putting things in standard form, but it's nice. It tells us what the vertex is. In fact, knowing this, we can answer a lot of questions about our graph. Let's think about what we can answer based on our graph. We know, roughly speaking, what that graph's going to look like. And let me just kind of squeeze it in here. So it's going to go down to the vertex at negative 3, negative 41. So for instance, I could tell where the graph is decreasing. It's decreasing on the interval negative infinity to negative 3. It's increasing on the interval from negative 3 to infinity. What's the minimum of this graph? Negative 41. So the range would be negative 41 to infinity. So there's a lot of information you get just by knowing that much and just by having this very, very simple image of the graph. Let's try problem number 52. So we're not going to have to dive into the graph so much with problem 52. So instead we've got a ball is being thrown across a playing field at a height of 5 feet above the ground and an angle of 45 degrees to the horizontal at a speed of around 20 feet per second. It can be deduced from physics that the path of the ball is given by this formula. So if you wanted to, you can graph this, and I gave you some suggestions for the window size. When I give it to you in this form, what I'm giving you is x min, x max, y min, and y max. So that's the values that I'm giving you here if you wanted to graph that. But what you're looking for here is to find the maximum height of the ball. Well, the maximum height of the ball is simply going to be the y-coordinate of your vertex here. How can we find that? There's really a couple ways, but the best way is to use this formula right here. Let's change that into a decimal. So you guys got to be kind of gun shy here. 32 divided by 400, what, 0.08? All right, so let's rewrite this as y equals negative 0.08 x squared plus x plus 5. And it might not be a bad idea to put that into our calculators to find some of these values. But the x-coordinate of the vertex is going to be negative b over 2a. Or, what's b in this particular case? 1. So negative of 1 over 2 times negative 0.08. So negative 1 divided by 0.16, so it's going to be positive something. 1 divided by... You're getting about 6 1/4? Michael? Somebody got it?
Yeah, 6 1/4.
All right, thanks. 6.25. Now that's where the maximum height occurs. But what is that maximum height? Well, how are we going to find that maximum height? I know when it occurs along the x-axis, but what is that maximum height? What should we do to find it? Yeah, plug in 6.25. So I'm going to do it this way. I'm going to plug in the formula negative 0.08 x squared plus x plus 5. And then I'm going to go, oops, thank you. Hit the second key and then the table button. Let me delete all these other values here. I'm just going to type in the value 6.25. And I get 8.125. So y equals 8.125. Before I write that down, is someone else getting that same thing? Okay. Just this one right here. The one that all I did was I put the decimal value as opposed to the way the book wrote it. So the book wrote it like this. I used the decimal value. Thank you. Let's set up the window per suggestion. So let me set my window from -1 to 17 along the x-axis and from -1 to 9 along the y-axis, and take a look at its graph. There's a couple ways you can find that maximum point. One of them is with the calculation features of your calculator. If you hit the second key, then the calc key, you can find a maximum that way. But let me just go back to the graph. For us, I think it's easier just to hit the trace key, and let's type in the value of x that we found. We found 6.25 for x. When you press the first number, it'll open up a line on the bottom row of your calculator so that you can see what you're typing in. When you press enter, on the bottom row of your calculator, you'll see the x-coordinate and the y-coordinate. So if you wanted to skip the table step altogether, you could. We get a maximum of 8.1285, or excuse me, 8.125, 8 1/8. As a good follow-up problem, you could be asked to find where the graph crosses the x-axis. The interpretation of that is where the ball hits the ground. So that's going to be somewhere around 16 feet. So as far as a football toss, it's pretty weak sauce. Maybe the guy's throwing the ball to his like 5-year-old son or daughter or something like that, but it's a pretty weak toss. All right, our concern though is to find the x and y coordinates of the vertex. Are you okay with that part? Let's take a look at one last one, problem number 56. So the formula here in problem 56 represents the concentration of a certain drug in a patient's bloodstream after T minutes. And so T is somewhere between 0 and 240, basically between 0 and 4 hours. It says, when is the maximum concentration reached, and what is that maximum concentration? Well, let's think about this graph here. And let me turn this around. Let's put this as negative 0.0002 t squared plus 0.06 t. What can you tell me about the shape of this graph? Which way is it going to face? Yeah, it's going to face upside down. All right, so the graph has to look like this somehow. What's that tell you about the vertex? If the graph faces down, is that vertex a minimum or a maximum? Maximum. If they want find out what the maximum concentration is, that's the y-coordinate of your vertex. When it occurs is the x-coordinate of your vertex. So it's just another application of finding the x-coordinate of your vertex and then the y-coordinate from there. So let's find the x-coordinate. X equals negative b over 2a. What values can I substitute in for a and b? Good. So for A, that's going to be negative 0.0002. So 2 times negative 0.0002. And B is negative of 0.06. Probably a calculation that I'd recommend doing on the calculator just to avoid any silly mistakes. Negative 0.06 divided by parentheses 2 times negative 0.0002. Oops. Didn't like that. That's what I was expecting. I'm just kind of curious as to why. Oh, I got an extra parenthesis there, I think. There we go, 150. So I get 150 for X. That's where the maximum concentration occurs. But what is that maximum concentration? How would we find that maximum concentration? John, any suggestions? I know that when it occurs, I should probably put a T here, not an X. It occurs at T equals 150. That's when we get the maximum concentration. Yeah, plug in 150 into the equation. Now I'm going to do it this way. I'm going to take 150 and store it in X. The store key is on the left-hand side down here at the bottom. And let's type in the equation. 0.06 times X minus 0.0002X squared. And I get 4.5. Someone else want to double check me on that before I write it down? Yes. Got the same thing? Okay. See, you made me nervous. All right, it's all right. So C of 150 is 4.5. Curious what the units would be on that one. Milligrams per liter. Milligrams per liter. Boy, that's tiny. That's really, really tiny. Yep, just plug 150 in. For homework, section 3.1, try 5 through 31, 37, 45, 51, and 53.